I'm Anil Kumar. Welcome to my series on quadratic relations word problems. In part 1, you saw solution of first 3 questions, and now let us take the solution of rest of them. Question number 4. The numerator of a fraction is 3 less than its denominator. If 1 is added to the denominator, the fraction is decreased by 1 over 15. Find the fraction. So we are saying that the numerator of the fraction is 3 less than denominator. So we'll begin with denominator. Let denominator equal to x. In that case, numerator will be equal to, it is 3 less than denominator, so x minus 3. Okay. So what is the fraction? So the fraction will be what? Fraction will be x over, x minus 3 over x, right? That becomes the fraction. Now it says, if 1 is added to the denominator, the fraction is decreased by 1 over 15. So 1 is added to denominator. So the other fraction is, in the denominator you add 1. So the other fraction is x minus 3 over x plus 1. So 1 is added in the denominator. Correct? So this is 1 is added to the denominator. So we added 1 in the denominator. Then it says the fraction is decreased by 1 over, so the fraction is decreased. So this is lesser, right? So it is decreased by 1 over 15. Correct? So that means the difference in these two is 1 over 15. Correct? So we get our equation. Perfect? So we get our equation as this minus this is 1 over 15. So we have x minus 3 divided by x minus x minus 3 divided by x plus 1 is equal to 1 over 15. Perfect. So that is how it can be solved. Okay. Now let us see how to solve this kind of an equation. Whenever you have equation in fractions, you have to multiply by common denominator. So the next step to solve this equation is multiply by common denominator. That is to say, you are going to multiply this by 15 times x plus 1. Correct? Everything. All these three. So let's multiply and solve. So what do you get? So let's do it now here. I think this part is absolutely clear, how we made our equation. Now how to solve the equation. So when you multiply this term by 15x times x plus 3, x is already there, so the numerator should be multiplied by 15 times x plus 1. So what we get here is x minus 3 times 15 times what is not there in the denominator, x plus 1. Next, we get x minus 3 times x and 15, right? So let me write 15x equals to 1 gets multiplied by x times x plus 1. Clear? Now on the left side you see x minus 3 is a common factor. So if you take a common factor and then simplify, it becomes simpler. So we'll do that. So it's a good technique, right? We should learn how to do also as we move along. So x minus 3 I took common. So I'll do multiply with this. So it is 15x plus 15 here. And from here we get minus 15x. On the right side, when you multiply, we get x squared plus x. Is that clear? 15x and minus 15x cancel, so we'll just multiply this by 15. So we get 15 times x minus 3 equals to x squared plus x. Much simpler, right? So as you can see, this cancels, right? Plus and minus. So it is much simpler. Only by 15 we have to now multiply. And then we have to take all the terms to one side. So we get here 15x minus 45 equals to x squared plus x. Taking all the terms to the right, we get 0 equals to x squared plus x minus 15x plus 45. Clear? So this can be simplified further, and we could write this as x squared minus 14x plus 45. Now it is a quadratic equation which you can easily simplify. So 45 is like 9 times 5. So we can factor this. So we can write this as 0 equals to x minus 9 times x minus 5. So we get two solutions here. One is x equals to 9. The other one is x equals to 5. Now in quadratic equations, you have to always check your solutions. Which one is correct? So that is to say, when I substitute 9 here, do I get 1 over 15 as a difference? When I substitute 5 here, do I get 1 over 15 as my answer? This is what. So let us check. So let's check for x equals to 9 first. So if I write 9 here, I get 9 minus 3 over 9. And there also we get 9 minus 3 over 9 plus 1, 10. Correct? So this is 6 over 9 minus 6 over 10. So clearly what we get here is when you multiply, cross multiply, 60, so 6 is common, you can say, right? So you get 90 here, and 10 minus 9 is 1. You get 1 over 90. You do not get 1 over 15, right? So that is definitely not the right answer. Now let's write down the other answer, x equals to 5 here. So let's check for x equals to 5. So if I write 5, I get 5 minus 3 over 5 minus 5 minus 3 over 6. Now here the common denominator is 30, and we get here 5 minus 3, 5 minus is 2, right? So it is 2 times 6 minus 2 times 5, correct? So which is 12 minus 10, or is equal to 2 over 30, which is equal to 1 over 15. So that is correct. Is that okay? So the right solution is indeed x equals to 5. Perfect. So x equals to 5 is the right solution. So we need to find the fraction. So the fraction should be equal to what? So our answer is, we'll substitute 5 here. So 5 minus 3. So 5 minus 3 and over 5, which is, so the numerator, so we have this 5 minus 3 is what? 2 over 5, right? So we have 5 minus 3 over 5, which is 2 over 5. So the answer is 2 over 5. This becomes, when I write 5 here, 5 minus 3 over 5, which is 2 over 5. Is that clear? So the answer is 2 over 5. So that is how it should be solved. I hope it is absolutely clear. Let's move on and take the next question. Question number 5. Tina bought some t-shirts for $80. If she had bought 4 more t-shirts for the same amount, that is $80, each t-shirt would have cost $1 less. Find the number of t-shirts she bought, right? So let the cost be, we'll say first list the number of t-shirts equal to, let us say number of t-shirts is n, right? We don't know. And let cost be equal to, in dollars, x dollars, correct? Then what we are given here is that n times x is equal to 80. That is what we are given. So both have been bought for $80. Now the second condition which is given to us is if she had bought 4 more t-shirts, that means the number is 4 more, n plus 4. For the same amount is $80. Each t-shirt would have cost 1 less. So the cost would have become 1 less dollar, right? And the amount is 80 only. So the equation is this times this is 80, right? So in this case, for the same amount, so when they say for the same amount, it means when you multiply these two, that is n plus 4 times x minus 1, you should again get 80. Do you see that part? So that is how you have to solve this particular equation. Correct? So I hope that concept is clear. So we need to now find the number of t-shirts she bought. Since we want to find number of t-shirts, we can actually use this equation to replace x with number of t-shirts, right? So what I'm going to do here is we have to find the number of t-shirts n she bought. So we'll write x as equal to 80 over n in this equation and solve. So I hope you got this strategy. So let us see how to solve it further. So we have our equation, which is n plus 4 times x minus 1 equals to 80. So if I multiply, we get n times x nx minus n plus 4x minus 4 equals to 80. Now nx, we could straight away write what nx is, right? Is 80 and n is 80 over, and x is 80 over n, right? So we could replace. So nx is 80, so I'm writing only 80 here, 80 minus n plus 4 times x. 4 times x means 80 over n, right? So I'm writing this as 4 times 80 over n minus 4 equals to 80. Is that clear? Okay. So that is how we get our equation. Now we can simplify this and write it as a quadratic equation. So first thing is, let's bring all the terms together, right? So we'll get all the terms together and multiply by n. So if I multiply by n, I get 80n minus n square plus 4 times 8 is 32, 320 minus 4n equals to 80n. Right? Now let's bring everything to the right side since this n square is negative. So we have 0 equals to, we have n square, we have 80n minus 80n, they will cancel, plus 4n minus 320. Correct? So when you combine these terms, they cancel, we are left with 4n here. So we have 0 equals to n square plus 4n minus 320. Correct? Now we need to factor this. Correct? So we need to factor and get the value of n. So how do you get so what two numbers can be multiplied to give you 320 and 4? So that could be 16 and 20, right? So we'll just factor this. Let me rewrite this. 0 equals to n square plus 4n minus 320. So we're trying to factor 320. Right? 16 times 20. If you do that, you get 320, and when you add, then you get 4n, provided this is minus 60 and that is plus 20, right? So we could write this as n minus 16, bigger number is positive, n plus 20, correct? So from here, we get two solutions. One is n equals to 16, the other one is n equals to minus 20. So you cannot have minus, so that is not valid. So the valid solution is n equals to 16, right? So this is the valid solution. So our answer is Tina bought 16 t-shirts. Is that clear? So that is how you are going to solve it. Perfect. So let's take the next question now. Question number 6. Present age of father is equal to square of the present age of son. 1 year ago, age of father was 8 times the age of his son. Find the present age of son. Since it is find the present age of son, we'll begin with let present age of son equal to x. Now it says present age of father is equal to square of present age of son. So present age of father will be what? X square. Perfect. 1 year ago. So if I see the scenario 1 year ago. So when I say 1 year ago, in that case son will be how old? Less 1 year, right? So son age will be x minus 1 and father's will be 1 less, right? X square minus 1. So 1 year ago, 1 year younger. Perfect. So 1 year ago, the age of father was 8 times the age of his son. So at this time, 1 year ago, father was 8 times. So you get your equation, which is x square minus 1 is 8 times x minus 1. Does it make sense to you? So it's kind of very important to get the equation, right? So in age problem, that is how you could do it. Now it is a simple question of expanding and simplifying, right? So open the bracket. So 8x minus 8. Bring them together. X squared minus 8x minus 1 plus 8 equals to 0. And that is x squared minus 8x plus 7 equals to 0. And you can now factor this and get the answer. So we have x squared minus 8x plus 7 equals to 0. 7 times 1. So we'll have minus 7 times x minus 1 equals to 0. That means x could be equal to 7 or x could be equal to 1. So it cannot be 1, right? So it has to be 7. So the answer is son's age is 7 years. Perfect. So that is how the age problem should be done. And now let's take the last question of our series. Now we are almost at the end. Here is question number 7. 3 consecutive integers are such that the sum of squares of the first and the product of the other two is 46. Find the integers. So when we say consecutive, that means they come one after the other. So let the integers be x, the other one will be x plus 1, then x plus 2. Correct. Now the condition given to us is, let's use another ink, we'll write down the equation and solve it. Sum of the squares of the first, that is x square, plus product of the other two, so that is, x plus 1 times x plus 2 is 46, So that is how you get your equation. Now let's solve it. So we have x square plus, when you multiply, you get x square plus 2x, plus when you do with 1, you get x plus 2 equals to 46. Bring them together. So we have 2x square, 2x plus x is 3x, plus 2, let me write like this only, and then we'll combine, correct? So we have 2x square plus 3x minus 44 equals to 0. Now we need to find product as of two numbers as minus 88 and sum of two numbers as 3. So what could be the numbers? Could be 8 and 11, right? And positive is positive, and bigger number is positive, and minus 8. That could give you this, correct? So let's use this and factor to solve. So we have 2x squared plus 11x minus 8x minus 44 equals to 0. Now x is common. We get 2x plus 11 here, and here we have 4 common. Negative 4, so we get 2x plus, this was 11, plus 11 equals to 0. Now 2x plus 11 is common. We get x minus 4 equals to 0. So this gives you x as minus 11 by 2, which is not an integer, and that gives you x equals to 4, which is correct, right? So that becomes our solution, x equals to 4. Now if x is 4, the 3 integers will be 4, 5, and 6, right? So the answer here is the integers are 4, 5, and 6. Perfect. So that is how you answer this particular question. So I hope you understand and appreciate how we can actually form equations and solve quadratic equation applications, correct? So we actually did 7 questions. We started with these, right? And completed the whole exercise. And that should give you a fairly good idea of how to work with word problems related to quadratic relations. Thanks for watching. Share my videos with your friends, and if you like and subscribe to them, that'd be great. All the best.